You are watching video on SEE Class 10 Subject Science. In this video series, we study chapters of Physics, Chemistry, Biology, Astronomy and Geology. So in this video, we are going to study Physics chapter 4 and it is part 6 of the chapter. Now in this part, we are going to study derivation of small g or acceleration due to gravity. Formula for acceleration due to gravity, g equal to gm by re square. Now in the same part we'll understand relation of acceleration due to gravity small g with the radius of the earth. Okay, how does value of g differ with the length of the radius of the earth? Now here we know the formula for Newton's universal law of gravitation, F equal to gmm by r square here or d square, right? So in this formula, capital M means mass of the earth here, small m is this one mass of the body which is lying close to the surface of the earth, and r is the distance between the centers of these two bodies. Radius is considered as distance between the centers of these two bodies, but you can see this length is not coming from the center of the two bodies, this body, but this distance is very much small, negligible. That is why it is considered as, the distance between the centers of two bodies. Radius of the earth is considered as distance between the centers of two bodies. So this way r square is same as d square. Now here from this formula what do we understand is F is same as gravity, because in case of gravity, when one of the body is planet or the satellite, planet like earth, then the distance, the force between two bodies, this body, small body with mass small m, and planet, can be called gravity. Okay, so gravity is the special case of gravitational force, right? So here it can be called gravity. That means F is same as gravity, and gravity is also equal to weight, because from the definition of weight we have understood that weight is the amount of pulling force of the earth towards a body, the body which is lying close to the surface of the earth. Yes, the force between these two bodies, small m capital M, small m capital M, can be understood as gravity, and gravity is equal to weight. Okay, that means this formula gives us calculation of weight, or we can write it this way. In place of F we can write W over here. W means weight. W equal to gmm by r square. Let this be equation number 2. Let this be equation number 1. Now, but we know another formula to calculate weight which we always use, that is W equal to mg, which is derived from Newton's laws of motion. Second law of motion. Second law of motion, F equal to ma, which can be written as W equal to mg also, because F equal to W, and here A is equal to acceleration due to gravity, right? So W equal to mg. Now we have two formulas to calculate weight. One is W equal to gmm by r square, other one is W equal to mg. So if both of these formula can be used to calculate weight, then this should be equal to this one. We can write it this way, W equal to W. Now let's substitute the values. Okay, this W equal to mg, this W is equal to gmm by r square, right? Now after substituting values, let's do calculation. So mg is equal to gmm by r square. On both sides there are small m's. Okay, small m's means mass of the body which is lying close to the surface of the earth. This m, this small m, in both sides. Okay, there is m. So this small m can be cancelled out. Okay, these are on either, m is on either side of the equal to sign. So this m cancel out, this m cancel out, right? So here is remaining small g equal to gm divided by r square. So this is the formula for acceleration due to gravity, g equal to gm by r square. This is the formula for acceleration due to gravity. We use this formula to calculate acceleration due to gravity. Now in this formula, if you look at it carefully, there is only capital M, there is no small m, and capital M means mass of the earth, and capital R is radius of the earth. That means acceleration due to gravity g depends on, the value of G depends on mass of the earth and radius of the earth. Mass of the satellite or the planet, or radius of satellite or the planet. Now in this equation we know capital G is universal gravitational constant, which is a proportional constant. Okay, now if you want to write this formula this way, G proportional to m divided by r square, then you need to remove equal to sign and proportional constant. By removing equal to sign and proportional constant, we can write proportionality sign. Right, in place of equal to and capital G, we can write this one. Okay, once you write this, you need not to write this. Okay, now you see G proportional to capital M divided by r square. Here capital M is the mass of the earth and capital R is the radius of the earth. Right, thus G depends on mass of the planet and radius of the planet. From this formula, what did we understand is acceleration due to gravity depends on mass of the satellite or the planet and radius of the satellite or the planet. There is no small m. Mass of the body is not there. So formula does not contain mass small m of the body which is lying close to the surface of the earth. Thus acceleration due to gravity is independent of the mass of the freely falling body. That is why we say acceleration due to gravity does not depend on mass of the freely falling body. Okay, acceleration due to gravity on a body, small body, falling down to the surface of the earth, small m, mass of the body, is not responsible for acceleration due to gravity. Okay, acceleration due to gravity is determined by mass of the planet and radius of the planet. That's all. Okay, we are going to see the next part here. You see variation in value of G due to the shape of the earth. Now we will see in this formula, we have been studying G equal to Gm by r square, which is the formula to calculate acceleration due to gravity. Okay, now this formula can be written this way also, G proportional to 1 by r square, because in this formula you see G is universal constant, capital M is mass of the earth, which is also a constant quantity. Okay, physical quantity, right? So capital G, capital M, mass of the earth, these are constant. Okay, so these are constant, not changing. That means the only changing variable factor is radius over here, right? Radius of the earth. So G proportional to 1 by r square. Now the value of G is inverse to radius of the earth. Means when G is big, r is small. When G is small, r is big. Inverse relation you can see from this formula. No, G proportional to 1 by r square. There is inverse relation of acceleration due to gravity with radius. Okay, now that is why we say variation in value of G due to the shape of the earth. Now radius is directly related with the shape of the earth. Shape of the earth means there is, radius can be of different length. Okay, now we know earth is not a perfect sphere. Okay, it is not perfectly round. It is little bit elliptical in shape, means oval in shape. It is just like an egg which is flattened at the poles and bulging out at the equator. Orange shaped. Okay, so earth is of orange shaped, and because of the shape of this earth, orange shaped, of the earth, or oval shape of the earth, what do we know is radius is different in length. Okay, at the polar region and the equatorial region, radius is of different length. Okay, from this shape of the earth, what did we understand is radius at the pole is shorter than radius at the equator. No, because of the shape of the earth, because orange shaped, right? So what do we understand? Radius at the pole is smaller than radius at the equator. Okay, radius at the equator is longer than radius at the pole, right? This is due to shape of the earth, oval shaped of the earth. Now polar radius is shorter than equatorial radius due to the oval shape of the earth, or we can write it this way, radius at the pole is smaller than radius at the equator, which means acceleration due to gravity at the pole is greater than acceleration due to gravity at the equator, because g proportional to 1 by r square. Acceleration due to gravity has inverse relation with the radius. Okay, when radius is small, g is big, and when radius is big, g is small. That is why acceleration due to gravity at the pole is greater than acceleration due to gravity at the equator. So g is greater at the pole, g is smaller at the equator. So this is understood. Now we see, or you can say it this way also, acceleration due to gravity is greater at the pole because radius is smaller. Acceleration due to gravity is smaller at the equator because radius is greater or the longer. Okay, so this way we have the values of acceleration due to gravity at the equator and at the pole. At equatorial region, the value of acceleration due to gravity on the surface of the earth is 9.78 meter per second square. This is the exact value of acceleration due to gravity at the equator. Now at the polar region, the value of acceleration due to gravity is 9.83 meter per second square. Right, you can see the value of g is greater at the pole. Okay, so there are different values for acceleration due to gravity on the surface of the earth. That is why, in order to avoid this confusion, we use a single value, common value for acceleration due to gravity, which is 9.8 meter per second square. All over the surface of the earth, we use acceleration due to gravity of the earth 9.8 meter per second square. This is just to avoid the confusion. Okay, the average value of acceleration due to gravity 9.8 meter per second square. That is why we use value g equal to 9.8 meter per second square. So how does the value of acceleration due to gravity change with the shape of the earth or the length of the radius at different places of the earth? So this is the topic and we understood it. Now we have little more explanation on the same topic, that is, you see here, variation in the value of g with the height from the surface of the earth. Now how does value of g differ due to the height of the due to the height, okay, with the increasing height? Variation of g with height from the surface of the earth. Now when the body is lying on close to the surface of the earth, value of g is 9.8 meter per second square. Now what happens to g when you take this body high up at this position? That is the question here. Okay, so you see g equal to gm by r square. We know this formula, acceleration due to gravity. Right, in this formula, g is universal gravitational constant and capital M is mass of the earth and capital R is radius of the earth. Okay, now we are going to rewrite this formula according to this condition. Yes, how to write g equal to gm by r square from this condition, given condition in the figure. Now acceleration due to gravity g from the given figure, when a body with mass m, small m, is kept at the height h from the surface of the earth. Now the body is not on the surface of the earth, it is at this height. So how to write the formula g equal to gm by r square? Here you write it this way, g equal to gm divided by r square. So here the value of g will be certainly different. Okay, on the surface of the earth it is 9.8 meter per second square, but when you take this body at height, obviously it is going to have different value. That is why it is not written g, it is written as g dash. Okay, let this be g dash. G dash equal to gm divided by, now the different situation is r plus h whole square. Radius has increased by the length h over here, no? So r plus h whole square according to formula. Radius has increased by h height, no? So r plus h whole square. So this is the formula in this condition. Now we are going to find value of g dash. Okay, then what is the value of g dash then? Okay, if it is not g, then what is the value of g dash at the height? So we are going to find that. How to find that? We can find it by comparing this with G. Comparing G dash with G. By comparing means it is dividing by finding the ratio. Okay. So equation 1 is divided by equation number 2. Equation 1, G equal to Gm by R square. This is equation 1. This is equation 2. Okay, when you divide equation 1 by equation 2, we can find the value of G dash. This can be calculated. Okay, so G dash divided by G means ratio is ratio is being calculated over here. G1 divided by G. So G1 means Gm divided by R plus H whole square over here, and this is G1 divided by, means this is divided sign. Okay, and G means Gm divided by R square. Okay, now in the next step, what are we going to do is G dash divided by G equal to Gm divided by R plus H whole square. When this division sign becomes multiplication, this fraction gets upside down. Okay, yes, reverse. So R square divided by Gm. Okay, it is upside down now, this fraction. Now let's do the cancellation. Gm cancel out. Then there remains only R square divided by R plus H, R square divided by R plus H whole square. Okay, so both R square is square, so that is why you can make them whole square. G1 divided by G equal to R plus H whole square. It can be written this way because both are square. Now next step, G1 equal to, now let's see, let's take this G to the right hand side so that you can find value of G dash. G dash should be made alone in left hand side. Okay, so in order to find its value, so G1 is equal to R plus H whole square into G. G is being divided over here, and when it goes that side it becomes multiplication. You know this. Now here, now this is the formula to calculate G dash. Okay, G dash, value of acceleration due to gravity at the height. How to calculate acceleration due to gravity at this height? That can be done by using this formula. G dash is equal to R divided by R plus H whole square into G. Now we know the value of G, it is 9.8. No, and you should have radius value and height. Okay, then we can calculate G dash. Now here you see R divided by R plus H is less than 1, because in this case numerator is smaller than denominator. Supposing R is equal to 1. Okay, if this is 1, then 1 divided by this R is also 1 then, because these are RR. Okay, 1, and let the height be 2. Let the height be 2 or 1, whatever. No, so 1 divided by 3. You will have fraction 1 divided by 3. And when 1 is divided by 3, you will get always decimal digit over here, right? It is always less than 1, right? So the value of this whole fraction is always in decimal point, less than 1. And when this less than 1 is multiplied with the value of G, 9.8, it is always less than 9.8. Okay, so when this G is multiplied with this decimal point, supposing 0.2 or 0.3, 0.4, then multiplication of these two will give you value less than 9.8. Right, less than 9.8, not greater. That is why G dash is always smaller than G. G dash is always smaller than G because of this calculation. Okay, because 9.8 is multiplied by decimal digit over decimal digit with decimal point. Okay, less than 1. Okay, so that is why it is smaller. Now here, so acceleration due to gravity decreases with increase in height. So what did we understand is acceleration due to gravity decreases smaller at this height.